I'm Dr.B.Krishnaveni, Assistant Professor in Mathematics, Aditya University. Today we are going to discuss about partial differentiation. In this, what we learn is how to do the partial derivatives as well, Euler's theorem for homogeneous function as well as chain rule and total derivative. That is, at the end of this lecture, student will be able to evaluate a partial derivative and can apply Euler's theorem, understand the chain rule and total derivative. So, this we can learn in this lecture. So, let us move to the lecture. First, we will start with partial differentiation. A partial derivatives of a function of several variables is the ordinary derivative with respect to one of the variables when all the remaining variables are held constant. So, it is also a derivative in which how to do the derivative with respect to two or more variables. So, if you deal with the derivatives, that is ordinary derivatives, it is the derivative about the function like dependent and independent variables. If you represent that with dy by dx, in which we all know that y is a dependent and x is independent. So, here we are doing calculating the derivative with respect to x, y with respect to x. So, means we are doing with respect to only one independent variables. But here while doing the partial derivative, we can do with respect to two or more independent variables. So, now if you see this, partial derivatives can be done and we call it as an ordinary derivative with respect to one variable while remaining variables are constants. Hence, the partial differentiation is the process of finding partial derivatives. Now, let us consider z is equal to f of xy be a function in two variables x and y. Then the derivatives of z with respect to x and y are denoted by dou z by dou x, dou z by dou y. And dou z by dou x is defined as dou z by dou x is equal to limit h tends to 0 f of x plus h comma y minus f of x comma y divided by h, provided limit exists. So, this gives the definition for partial derivative or partial differentiation. Now, here you can see dou z by dou x and dou z by dou y call as first order partial derivatives, and dou square z by dou x square, dou square z by dou x dou y and dou square z by dou y square, we call those are second order partial derivatives. So, now let us do the questions on partial derivatives. The first problem is find dou f by dou x, dou f by dou y for f of x comma y is equal to log of root of x square plus y square. So, for the function f of x comma y, we have to calculate dou f by dou x, that is partial derivative of f with respect to x, and dou f by dou y, which nothing but partial derivative of f with respect to y. Now, let us consider the function f x y log of root of x square plus y square, which can be written as log of x square plus y square power 1 by 2. So, which further can be written as 1 by 2 log of x square plus y square. So, now let us calculate dou f by dou x and dou f by dou y. So, while doing the partial derivative with respect to x means we need to keep y constant. So, now let us see what the derivative will be. 1 by 2 into first log derivative. What log derivative will be? 1 by the function, that is x square plus y square, into the inner derivative. What derivative is? Partial derivative with respect to x. So, which is given by dou by dou x of x square plus y square. That will be equal to 1 by 2 into 1 by x square plus y square into, now x square derivative is 2x and y is constant, the derivative is 0. Then here 2 gets cancelled and you got dou f by dou x is equal to x by x square plus y square. Now, let us find out dou f by dou y, in which x is constant. So, same as it is, first we need to start the derivative with the log, that is 1 by 2 log derivative is 1 by x square plus y square. Now, inner derivative means partial derivative with respect to y of x square plus y square. which equals to 1 by 2 into 1 by x square plus y square. Now, what derivative with respect to y is 0. X square means constant, derivative 0, and y square derivative is 2y. Again 2 cancel, we got the answer is equal to y by x square plus y square. So, therefore, dou f by dou y is equal to y by x square plus y square. So, that is, we calculated the first order partial derivatives for the given function f of x comma y. Now, the next question is, the question is about the verification of dou square u by dou x dou y is equal to dou square u by dou y dou x. For the function u is equal to tan inverse of x by y. So, here there are two aspects you can observe from the given partial derivatives. So, here the first one is doing the partial derivative first with respect to y then x. The second one is doing the partial derivative first with respect to x then y, and need to show that both are same. Now, let us consider the given function u is equal to tan inverse x by y. Let it be equation number 1. So, do derivative with respect to x, that is dou u by dou x, where y constant. First, tan inverse derivative is 1 by 1 plus x by y whole square. Inner derivative, that is partial derivative with respect to x of x by y. So, which gives 1 by, the denominator becomes y square plus x square by y square, and dou by dou x of x by y means y constant, which gives 1 by y. So, 1 y gets cancelled and you got that is equal to y by x square plus y square. So, now do the second equation, that is dou u by dou x, differentiating with respect to y now. That is dou by dou y of dou u by dou x, which is equal to dou by dou y of, just now we calculated what is dou u by dou x is y by x square plus y square, which implies dou square u by dou y dou x is equal to, now with respect to y we are calculating and both the numerator and denominator contains a y. So, apply the derivative of u by v, apply u by v rule in derivatives. So, u is a y and v is x square plus y square. So, first do u dash, that is y derivative is a 1 into v x square plus y square minus u into y into v dash x square plus y square with respect to y is 2y divided by v square x square plus y square whole square. So, now simplify x square plus y square minus 2y square, which gives x square minus y square, and the denominator is x square plus y square whole square. So, let it be equation number 3. Now, do the partial derivative, that is differentiating one partially with respect to y, that is dou u by dou y, where x is constant. So, the first one is, equation is u is equal to tan inverse x by y. Now, what is u with respect to y is, first tan inverse derivative 1 by 1 plus x by y whole square into the inner derivative of the function, that is dou by dou y of x by y, which is equal to 1 by y square plus x square by y square, and dou by dou y of x by y, x constant, 1 by y derivative is minus 1 by y square, which gives minus y square gets cancelled, x by x square plus y square. Now, again differentiating this fourth equation with respect to x, which gives dou by dou x of dou u by dou y is equal to dou by dou x of dou u by dou y is minus x by x square plus y square. That implies dou square u by dou x dou y is equal to, again numerator denominator contains x, apply u by v rule for derivatives, u dash 1 into v x square plus y square minus u into x into v dash with respect to x, that is x square plus y square derivative with respect to x is 2x divided by v square, which is x square plus y square whole square, that is equal to x minus of x square plus y square minus 2x square, that is y square minus x square, before we have minus. So, which can be written as x square minus y square by x square plus y square whole square. Let us representing this as equation number 5. Now from equation 3 and 5, what is equation number 3 is dou square u by dou y dou x. We got that is equal to x square minus y square by x square plus y square whole square. And equation 5 is dou square u by dou x dou y. Again that is equal to x square minus y square by x square plus y square whole square. So both are equal. So we conclude that dou square u by dou x dou y is equal to dou square u by dou y dou x. So now let's discuss about a homogeneous function. So what is meant by homogeneous function? Suppose let us consider the function f of x comma y and is said to be homogeneous function of a degree or order n in variables xy if f of kx comma ky is equal to k power n into f of x comma y, where n is a real number. So what homogeneous function is? We can say that fxy is homogeneous of a degree or order n if f of kx comma ky is equal to k power n into f of x comma y. Here n is a real number. So let's see the example for this. The function is fxy is x square plus y square. So do f of kx comma ky, which is equal to kx whole square plus ky whole square. That is k square into x square plus y square. K square into what this x square plus y square can be written as f of x comma. So clearly we say that f is homogeneous of a degree n. So here what n is 2, that is degree 2. So now let's state the Euler's theorem for homogeneous function. Let us consider z is equal to f of x comma y, which is a homogeneous function of a degree n. Then x dou z by dou x plus y dou z by dou y is equal to nz for every xy in the domain of the function. Then we say that f, that is z, is a homogeneous function. Here z will be a homogeneous function of degree n. Then it need to satisfy this for every xy in the given domain of the function. So that we call it as Euler's theorem. So here you note that if z is equal to f of x comma y is homogeneous function of degree n, then x square dou square z by dou x square plus 2xy dou square z by dou x dou y plus y square dou square z by dou y square is equal to n into n minus 1 into z. So which gives the Euler's theorem for homogeneous function. So now let us apply Euler's theorem in order to find out the partial derivatives or the evaluation of this kind of questions very easily. So now let us apply Euler's theorem for this. Find x dou z by dou x plus y dou z by dou y using Euler's theorem for u is equal to x cube y cube by x cube plus y cube. So in order to apply Euler's theorem, first need to verify whether the given xy must be homogeneous or not. Then only you have to apply Euler's theorem. So for that, first take the given function u is equal to x cube y cube by x cube plus y cube. So find out u of kx comma ky, which is equal to kx whole cube into ky whole cube divided by kx whole cube plus ky whole cube. So on simplification, k cube x cube y cube divided by k cube x cube plus k cube y cube, that will be equal to k cube x cube y cube divided by k cube into x cube plus y cube. So here k cube gets cancelled and you got this is equal to k cube into x cube y cube divided by x cube plus y cube, which is equal to k cube, and this is nothing but u of x comma y. So hence we say that u is homogeneous function of a degree n. Here what n is equal to 3. That is the given function u is homogeneous of degree 3. Now by Euler's theorem, we know that the Euler's theorem, what Euler's theorem is? X dou u by dou x plus y dou u by dou y is equal to nu. Here n is equal to 3, that is 3. This will gives, or you can simplify easily by using Euler's theorem. Now the second question is about verify Euler's theorem. So what Euler's theorem is? So just given statement, This is Euler's theorem. That is, if Z is homogeneous of a degree n means x into dou z by dou x plus y into dou z by dou y is equal to nz. So, you can apply Euler's theorem to get the answer very easily. Now, the question is about verification. In order to verify Euler's theorem, you have to show that LHS is equal to RHS. Hence, here the function is a Z, and first need to verify whether it is homogeneous or not. So, check whether it is homogeneous or not. If we take kx, ky instead of xy, you will get definitely it is a homogeneous, and it is a homogeneous function of degree 2. So, now in order to verify Euler's theorem, what you have to prove that x dou z by dou x plus y dou z by dou y is equal to nz. What n is? Degree. That means you have to show that x dou z by dou x plus y dou z by dou y is equal to 2z. Now, to prove that LHS is equal to RHS, first we need dou z by dou x and dou z by dou y. First find out dou z by dou x keeping by constant, that is dou by dou x of ax square plus 2hxy plus by square, which is equal to a into 2x plus 2h into 1 into y is constant, plus by square is constant, derivative is 0, which is equal to 2ax plus 2hy. Next find out dou z by dou y. In that x is constant, that is equal to dou by dou y of ax square plus 2hxy plus by square. Now x constant, so ax square constant, derivative 0, 2hx and y derivative is 1 plus b into y square derivative is 2y, which is equal to 2hx plus 2by. Now take LHS, that is x dou z by dou x plus y dou z by dou y. X into dou z by dou x is 2ax plus 2hy plus y into dou z by dou y 2hx plus 2by. So, which is equal to 2 into ax square plus 2hxy plus by square. So, that is 2 into what this will be? Z, which is 2z. Verified Euler's theorem. So, here the statement we proved, hence Euler's theorem is verified. The next question is, you have to calculate x dou u by dou x plus y dou u by dou y using Euler's theorem for u is equal to cos inverse of x plus y by root x plus root y. So, now take the given function u is equal to cos inverse of x plus y by root x plus root y. So, if you observe this, if you do u of kx comma ky, clearly it is not a homogeneous. So, once you see that u is equal to cos inverse of kx plus ky, that k into x plus y divided by root kx plus root ky. So, not able to resolve into u is equal to k power n into u. So, that means directly u is not a homogeneous function. So, now let us rewrite that as cos u is equal to x plus y by root x plus root y. Let us take the function will be z of xy. So, now apply on z whether it is homogeneous or not, that is z of kx comma ky is equal to kx plus ky by root of kx plus root ky, which is equal to k into x plus y by root k into root x plus root y, which is equal to k power 1 by 2 into x plus y by root x plus root y. What this will be? Z, k power 1 by 2 into z of x comma y. So, that means z is homogeneous function of a degree n is equal to 1 by 2. So, now let us apply the Euler's theorem on z. Then what will be the equation you will get by Euler's theorem? X dou z by dou x plus y dou z by dou y is equal to nz. This is Euler's theorem, which implies x dou z by dou x plus y dou z by dou y, n is 1 by 2 into z. Let us take this as equation number 1. But what z is equal to? Cos u. That means u is a function of, again what is u is? So, you can see here u is a function of xy and we have taken z is equal to cos u. If you need dou z by dou x in this, we need to find out like dz by du into dou u by dou x, which is equal to what cos u derivative is minus sin u into dou z by dou x, comma, dou z by dou y is equal to dz by du into dou u by dou y, that will be equal to minus sin u into dou z by dou y. Now 1 implies, what 1 can be written as x dou z by dou x, that is minus sin u dou u by dou x, this is u, plus y into dou z by dou y, that is minus sin u into dou u by dou y, is equal to 1 by 2 into z, what z is cos u. Now which this can be written as x dou u by dou x plus y dou u by dou y. You can take minus sin u to the RHS, which becomes minus 1 by 2 into cos u by sin u. Finally, the equation becomes x dou u by dou x plus y dou u by dou y is equal to minus 1 by 2 cot u. Now next is about the chain rule. In this we will learn about chain rule and total derivative. So first let's start with exact differential. If we consider the function phi in xy, d phi is equal to dou phi by dou x into dx plus dou phi by dou y into dy. We call this as exact differential of phi. So that is, if you take any function z is equal to xy, if you want to find exact differential, what exact differential formula is? Dz is equal to dou z by dou x into dx plus dou z by dou y into dy. So d of xy is equal to dou z by dou x, that is y dx plus dou z by dou y, which is x dy, gives the exact differential. So now let's move to chain rule. First let's know what is meant by total derivative or total differential coefficient. Now again take z is equal to f of x comma y, where x is equal to phi of t, y is equal to psi of t. Then dz by dt is equal to dou z by dou x into dx by dt plus dou z by dou y into dy by dt. We call this as total differential coefficient or total derivative of z. Now if you take z is equal to f of xy, where x is a function in uv and y is a function, again another function in uv, then how to find out dou z by dou u? Dou z by dou x into dou x by dou u plus dou z by dou y into dou y by dou u. And dou z by dou v is equal to dou z by dou x into dou x by dou v plus dou z by dou y into dou y by dou v. We call this is chain rule. So now let us understand the chain rule and total derivative by discussing these questions. If z is equal to x square plus y square, where x is equal to at square, y is equal to 2at, then find dz by dt. And we know that dz by dt is equal to dou z by dou x dx by dt plus dou z by dou y into dy by dt. First find out dz by, that will be equal to dz by dt is equal to dou z by dou x. Z is x square plus y square. With respect to x is 2x, y square is 0 into x is at square, dx by dt gives a into 2t plus dou z by dou y. Now x constant, x square derivative 0, y square derivative is 2y into, and given y is 2at, dy by dt is 2a into 1. So that is equal to dz by dt is equal to 4a xt plus 4ay. Now in this substitute what is x and what is y? That is at square and 2at respectively. You got dz by dt is equal to 8a square tq plus 8a square t. Now the next question is about chain rule. Given u is equal to f of r st, where r is equal to x by y, s is equal to y by z, and t is equal to z by x. Here given, we will start the function with 3 variables, that is r, s, t, and again each function, that is r, s, t, are in terms of 3 variables x, y, z. and we need the value of dou u by dou x, dou u by dou y and dou u by dou z. Okay. So, which means in order to find out this value, first of all we need the partial derivatives of dou u by dou x, dou u by dou y and dou u by dou z. So, first take our given function, what is r, what is s and what is t. Find out dou r by dou x with respect to x 1 by y and x derivatives 1. Dou r by dou y, x is constant, 1 by derivatives minus 1 by y square. And what is dou r by dou z is no z term, x by y is constant, derivative is 0. Next, dou s by dou x, no x constant it is, so derivative is 0. Next, dou s by dou y, 1 by z, dou s by dou z, y into 1 by z derivatives minus 1 by z square. Coming to the function t is equal to z by x. Now, dou t by dou x, z into 1 by x derivatives minus 1 by x square. Dou t by dou y, constant it is, derivatives is 0. Dou t by dou z, z by x 1 into 1 by x, that is 1 by x. Now, apply the chain rule of partial derivatives. First, let us see what is dou u by dou x is. Since u is in R, what are the three functions? R, S, T, and further that R, S, T are in terms of x, y, z. So, what the chain rule with regarding to dou u by dou x is? Dou u by dou r into dou u by dou x plus dou u by dou s into dou s by dou x plus dou u by dou t into dou t by dou x, which is equal to dou u by dou x is equal to dou u by dou r into dou r by dou x. Already we calculated here the values. What is dou r by dou x? So, substitute those values here and find out x dou u by dou x. Let represent that with equation number 1. Next, what is dou u by dou y is? Dou u by dou r into dou r by dou y plus dou u by dou s into dou s by dou y plus dou u by dou t into dou t by dou y. That gives dou u by dou y is equal to dou u by dou r minus x by y square plus, that is dou r by dou y, dou u by dou s into substitute dou s by dou y, that is 1 by z, dou u by dou t into dou t by dou y values is 0. And what y dy dou u by dou y is minus dou u by dou r x by y plus dou u by dou s into y by z. Let us represent that with second equation. Next, find out dou u by dou z. By chain rule, this will be equal to dou u by dou r into dou r by dou z plus dou u by dou s into dou s by dou z plus dou u by dou t into dou t by dou z. On doing this, we got z dou u by dou x is equal to minus dou u by dou s into y by z plus dou u by dou t into z by x. Represent that with equation number 3. Now, finally, what we need to find out? We need to add these 3 equations which gives our given question. If we add these 3, we will get x dou u by dou x plus y dou u by dou y plus z dou u by dou z. And what RHS will be? Adding all the terms, and if you simplify, these 2 terms gets cancelled, minus plus minus plus. You got the answer is equal to 0. That is, we got x dou u by dou x plus y dou u by dou y plus z dou u by dou z is equal to 0. In this lecture, what we learnt is, we come to know how to evaluate partial derivatives, and we got what is meant by homogeneous function and the Euler's theorem for homogeneous function, and how to apply this Euler's theorem on the given question. And we can understand what is chain rule and total derivative. Thank you.